Today we're looking at section 7.4. We're still solving systems of equations, only now we're going to have non-linear equations, so they're not going to only be lines. If you look at this first example of the system we're going to solve, the first equation here has an x squared in it, so the first equation is a parabola. The second equation is a line. So right now we're looking for where a parabola and a line are going to cross. Now notice we can have some possibilities. We might have two solutions. We might have one solution. We might even have no solutions. So we're going to have some options here. We're going to have some possibilities. And we're just going to go ahead and look and try to solve this system. Now, really quickly, when I look at this second equation, I think it's pretty easy to solve for y. If I add a y to both sides and subtract a 9, I get 3x minus 9 equals y. Now, there's my bottom equation, and if I look at the top, it looks like now I can use a little bit of substitution. I'm going to take 3x minus 9 and substitute it in place of the y. If I do that, we get x squared equals 2. Now, don't forget, you're going to have to distribute here, times 3x minus 9 plus 10. So x squared equals 6x minus 18 plus 10. And remember, when we have equations with x squareds, we like to get everything on the same side of the equation. So we're going to get of the equal sign. X squared minus 6x, and that's going to end up with a plus 8 equals 0. I'm trying to solve for x right now. I have x squared plus 6x plus 8 equals 0. We're trying to solve for x. So we're going to go ahead and either use the quadratic formula or factor. Now remember, when there's no coefficient in front of the x squared, it's easy. We're looking for two things to multiply to 8 and add to negative 6. You can also use your diamond and your rectangle if you need to. I'm going to get x minus 4 and x minus 2. So I have two answers for x now, 4 and 2. I want the y value for each of those. So you can see this is like this first case here where it crosses twice. Now to get the y, I'm going to go back to my original y equals 3x minus 9 and plug in the 4 first. 12 minus 9 is 3. So we get 1.43. And I'm going to do it again with the 2. So we get 6 minus 9, which is negative 3. And so you can see that at 4, 3, and at 2, negative 3, not 4, 3, negative 3. This parabola and line cross. Now if I go to the next slide for a minute, you can see that this is a picture of those two equations, and these are the 2 points where they cross. All right, let's look at the next one. X minus y equals 3, and x minus 2 squared plus y plus 3 squared equals 4. Now the first equation again is a line, and what kind of equation is the second one? I hope that you're thinking that it's a circle. Now, a line with a circle, think of all the options here. We could have 2 points, we could have 1 point, we could even have no points. So we can get a lot of options here again for answers. Now, we're going to go ahead and use substitution once again, just like we did in the last one. This time, let's take the top equation and solve for x. It's a pretty easy one. You could solve for y too, but I'm going to add y to both sides. And I get 3 plus y, or y plus 3. And now, we can use substitution, and then we're only going to have y values. So we're going to have 3 plus y minus 2 squared plus y plus 3 squared equals 4. If I combine like terms over here, it's y plus 1 squared. All the rest of this stays the same. Now I'm trying to solve for y. I'm going to have to go ahead and square both of these with rectangles. So you might want to use 2 rectangles there for each of those, right? One for the y plus 1 and the other for the y plus 3. When I do that for the first rectangle, I'm going to end up with a y squared, 2 y's, and a 1. In the second rectangle, I'm going to have a y squared, 6 y's, and a 9. Just like the last one, we're dealing with a quadratic, so let's combine like terms and get everything to the same side. 2y squareds, 8y's, 10, take away 4, and plus 6 equals 0. Now, I'm going to factor, but before I factor, I'm going to make my numbers a little smaller. You don't have to do this part. You can just go right to your diamond and your rectangle to factor. But I see that everything has a common factor of 2. I'm going to divide everything by a 2 on both sides. Now, when I do that over here, I'm going to have y squared, 4y, and 3. And you can see that it makes my factoring a lot easier. I'm looking for 2 things to multiply to 3 and add to 4. And that's easy, 3 and 1. So we get 2 solutions, -3 and -1. Just like the last one, we need to find x now for both of those. So I'm going to start with -3 and plug that in for y, and I get 0. So 0, -3 is one solution. And I'm going to do it again for the -1. And I get 2 for x. So 2, -3 is the other solution. I'm sorry, 2, -1. And now I have my 2 solutions. So you can see that this is a case where the line crosses the circle twice. And if we look at the next slide, I have a picture of how this happens. And you can see if I were to graph those, that's what it would look like. Let's look at another one. 4x squared plus y squared equals 13, and x squared plus y squared equals 10. Now these are both circles. So we have 2 circles here. Now, 2 circles, they might not cross at all. They could cross in 2 spots. Or, depending on what they look like, they might cross in 4 spots. So now we could have no solution, 2 solutions, 4 solutions. Can you think of a time where it would just cross once? We might even only have 1 solution. Lots of options here. Now, if I look at the way these are set up, this looks like a really nice option for elimination. Things are lined up really nicely. I'm going to go ahead and multiply through the bottom equation by a negative and add these together. I'm going to get 3x squared, the y squareds go away, equals 3. X squared equals 1 when I divide. And when I take the square root, I get plus or minus 1. Remember, when you square root an x squared, you get positive or negative. So now I have 2 options for my x's. I'm going to use the original x squared plus y squared equals 10 to find the y's. So I'm going to use this one here. It's the simplest one. And I'm going to start with positive 1. So I'm going to get 1 squared plus y squared equals 10. So y squared equals 9. So y is plus or minus 3 when I take the square root. So the x value 1 has 2 answers, 3 and -3. Are you seeing how this is going to be an example of 4 solutions? I have to do the same thing with the -1. Again, when I subtract positive 1, I get y squared equals 9. So we get the same thing, plus or minus 3. So for -1, we can also have 3 or -3 as answers, and we get 2 more solutions. So this one has 4 solutions, and let's go ahead and take a look at what that looks like on a graph. You can see there's those 2 circles, and they cross 4 times. All right, so looking at this last example, we're dealing here with an x squared, a parabola, and then an x squared and a y squared, so a circle. So we have some options here for a parabola and a circle. They might cross 4 times, they might cross 1 time, they might not cross at all, or we might have 2 solutions. So lots of options here. Now my first thought would be to go ahead and use substitution and put that in for the y. Now if I do that, I'm going to have the x squared plus 3 squared. Now when I do that, I'm going to end up with an x to the 4th. Now, we don't have a lot of good methods for solving x to the 4ths. So that substitution isn't a good route to go. So let's go back and let's look again at a different way. Now I'm going to take this top equation and I'm going to get the variables on one side. So it's going to be -x squared plus y equals 3. I'm going to try elimination. So I'm going to go ahead and write that one out. -x squared plus y equals 3. And then the other equation, I'm going to line up the things the same. So we'll put the x squared under the x squared. Now the y squared is going to have to go out here on the side, equals 9, because the y squared can't go with the y. You can't put those together. We'll put some zeros in there just as placeholders. And now if I add these together, the x squareds go away. I have a y plus a y squared equals 12. And if I get everything to one side, and I'm just going to do a little reordering here, I get y squared plus y equals 12. Y squared plus y minus 12 equals 0. This is an easy factoring. I'm looking for 2 things to multiply to -12 and add to +1. So that's going to be plus 4 and minus 3. And we get 2 solutions for y. Now I'm going to take both of those and I'm actually going to plug them into the very original equation to try to find the x's, the very top one right up here. So we're going to have -4 equals x squared plus 3. When I subtracted 3 from both sides, I'm going to get -7 equals x squared. Now that never happens. There's no solution there. So -4 actually doesn't give us any answers that work. If I do the same thing for the -3, I get -3 equals x squared plus 3. And I'm sorry, this isn't a -3 over here. We go back for 1 second. It should be a +3, shouldn't it? When I use the zero product property. So I'm going to get +3 equals x squared plus 3. So 0 equals x squared. So x equals 0. So this one only crosses once, and it's at the point 0, 3. And we can go ahead and take one look at the slide there, the last slide, and it shows that that circle and parabola cross 1 time. And that's where we're going to end this video for today. We'll practice these tomorrow.